Hey, thanks for tuning in. I'm Jacob Holcomb. I'm a principal security analyst here at Independent Security Evaluators. I'm directing the newly founded ISE Labs research division here at ISE. Today we're going to be hosting a live stream where we're going to go over some technical content. I have my colleague Ian Sinderman here. He's going to be giving you guys a technical demo, and I'll give him a minute to introduce himself.
All right, well, I'm Ian Sinderman, again at ISE, part of the research lab team. I'm associate security analyst. I've been here around a year or so. Started out as an intern, and I guess we're going to be focusing on the Seagate Personal Cloud SNR 21C, something like that. It's got this really fun authentication mechanism that is a right pain in the butt. So we're going to break it, and we're going to take you along for the ride.
Going to be pretty awesome content. So, before we get started, I just kind of want to say that, Ian, I mentioned, he's started as an intern 6 months ago. He came in. He didn't really have a lot of experience conducting professional security assessments, if you will. And since then, he's grown into a high caliber analyst here. So I'm going to give you a little plug. We're definitely looking for talent. So if you're interested in doing the type of work that we're going to be demonstrating on these live streams and publishing in the months to come, I encourage you to apply. We have many positions listed on our website, so you can check it out. It's securityevaluators.com. And with that said, I'm going to hand it over to Ian, and he'll kind of go through the content. We'll end with a question and answer, and we'll kind of talk a little bit more about the vision for ISE Labs and how and when, how frequently we'll be publishing content. So yeah, Ian.
All right. So I guess we're going to start out with just going over what the issue we're trying to overcome is. So we have this NAS device, we have the web interface, and we can log in, do all that fun stuff. I'll log in. Oh, at least I'll try to log in. There we go. And while this is happening, I'm using a tool called Burp Suite to kind of act as a middleman between my browser and the device. It intercepts all of my web requests and responses and allows me to A, view them, B, use automated tools, and C, manipulate things. So we can see all of our requests flying by over here. Go back to the main page. And we've got a whole bunch of fun attack surface. Now, I'll just try generating a few requests to kind of demonstrate the problem that we're going to be facing. So when attacking one of these devices, I'm really looking for ways that I can get really deep into it, somewhere that I can get command injection, ideally, or some way that I can get root. And a good place for that is in networking configurations. These are places where the application will oftentimes run system commands. So sometimes you can run command injection. So we'll just try changing the host name here. We'll go back to Burp Suite, see the request go by. And then I can send it to repeater, which, as you might imagine, just allows me to resend these requests and modify them. So you can see that if we take the request as is and try and send it, it works perfectly fine. But if we change so much as one character in the post body, we get a big fat 401 to the face. Now, that's a problem. We can see some fun things here, like the path of the file that caused this issue. So we see that it's running on Python. We have the web root, all that fun stuff. That could come in useful later on, but for now, we just know that we don't have access. But it's not like the application logged this out or anything. So something weird is going on here. And we can see that there is an authentication header using apparently some sort of HMAC. Now they call the header HMAC SHA1 date. I'm familiar with HMACs and SHA1s, but I'm not familiar with this combination. So that will be something we have to look into. We can see down here, this is just a whole bunch of random text. To me, that looks like base 64. So we'll just try finding out. and apparently parts of it are. Like we can see my username, and then a colon, and then a whole bunch of junk. So that's not super helpful, but at least we know that our username is there. Let me go back, we can try, so what if we send it back to the original request? See that, hey, that still works. We can change other portions of the request, such as just changing the host name, but it's still not, it's still gonna let us do our thing. We just can't change the post body contents or up here without really breaking anything. And that is because of the HMAC. For anyone not familiar with HMAC, with what HMACs are, it's kind of like a message integrity. Yeah, it's used for message integrity for the most part. A client and a server will have a private key or a pre-shared key, and they will use that to sign the message. As long as the attacker doesn't have that private key, the attacker can still modify the message and even the signature, but the signature will not correlate to the message once either one has been modified unless the attacker has that inside information. So we can modify anything we like here, but since we can't fix this signature, the server is going to deny it. So that's something we need to overcome, because currently we can't do any automated or even manual scanning. I can't try command injection without trying to do it through the web panel, and that just gets really, really, really ugly. So we're going to figure out a way around that. Now, first up, I'm just going to Google it, because chances are someone else has encountered this and we'll just be able to use that. So that's what I've done here. I've just typed in the header, and we can see some results. A lot of them are not super helpful, just because Google just thinks it knows better than I do for my search requests. But we can see some things down here. Like this is related to a NAST. It has the same header. That could be something useful, so let's check it out. We see that someone is working with a similar device, trying to do something similar to an extent. And then everyone just says log in and doesn't really tell you what to do or how to do it or even understand the issue. So that's not helpful whatsoever. So we'll keep looking. And then we get down here. As far as I can tell, this is some faculty for an Australian university. They made this, I guess they were looking to control portions of their NAS. They wanted to tie it into a monitoring suite. They used a tool called Ajax Explorer. I looked around. I couldn't find anything useful in that tool, but apparently they found something, so that's something to note down. We also see that they made a file called healthcheck.py that apparently implements some form of this authentication header. So that's something that I'd really like to look at. With any luck, we'll be able to download this file and just have Python code that tells us how to write this header. So I'll try to download it. Fun fact, that was not supposed to work. When I was doing this assessment, our good friend Castro here had misconfigured their web server, so when I tried to download this wonderful tool, I just got a big fat 401 to the face. Go figure that for the demo it works perfectly fine. We'll just ignore that for now. So imagine that we went to download this file and we had our hopes and dreams crushed by a 401. We can go back to Google, look around, but there isn't anything else. So we'll have to do it manually. To do that, I'm going to go back to my browser. And we know that for this header, my browser has to know how to generate it, because it sends a new one with each request, and they're different with each request as well. We can go back to Burp and demonstrate that. See that, these authentication headers, they change with each request. So my client has to know how to make those. And we can look and see, hey, are these coming from the server? Does the server tell us what to send? And in this case, it does not. But since our browser has all of the requisite information, we can start poking around at the browser's brainy bits and pull out the information we need. Or at least we can try. So to do this, I'll pull up just the browser's built-in developer tools. Pretty much any browser is going to have these. I'll go to sources and start using the the JavaScript debugger. This is something that allows me to tell the browser, hey, when you encounter, this certain set of things or this portion of the code or whatever, just stop executing that code and let me poke at it. Let me see what's going on, let me change values, that sort of thing. So I know that my request, or at least the one that I'm targeting currently, is going to this API endpoint to set the host name. And I also know that the debugger has a thing called XHR or fetch breakpoints. And this allows me to insert a breakpoint that is encountered whenever the browser tries to make a request containing that, with the URL that contains that string. So I've set one of those up. We'll enable that, and we'll try making the request again, see if the browser hits that breakpoint. Hopefully it does, but I don't trust JavaScript, to be honest. And it does, wonderful. And we get a nice big window full of gunk. We can try prettying it. Hopefully that works. And it does, wonderful. So now we can see a lot of useful information. You can see that the code broke right here. This is where the code tried to send that request. So from there, we can see the call stack. And this is essentially saying that, hey, this function WKD called VKD, and we're currently in VKD, and we can just step backwards. We can also see the current scope. We see all the variables that we have. We have our HTTP method, our current URL. Make that a little bigger for you. What we don't have is how the message, or the HMAC message, is formatted and what credentials are being used. Now, normally for an HMAC, it just uses the password, but we'll want to verify that. So going back to the call stack, I think I'm just going to walk backwards a bit, see how we got to this function. Because chances are, when we're already sending the request, we've already done all of the previous operations well in advance. So let's step back. This doesn't look interesting whatsoever. Step back more. This does look interesting. Step back a little more. More gunk, so we'll prettify it. Let me see. Here it's setting the URL, so that's probably too far. We know that to get to that hostname, or to get to that, to make that HMAC, we have to have that information already. So if we don't have that yet, chances are we probably haven't generated that HMAC yet. So we'll go back down. Now this function looks interesting to me. You can tell that I've already set a breakpoint here, so we'll just leave that where it is. And I think I will resume code execution and get back to this. So I'll wait for this current operation to finish. Here we go. Actually, I'm going to skip this a little bit. I'm going to turn off breakpoints because this portion of the function, or this portion of the code, is being hit by a lot of other requests that I'm not interested in. So I'll just turn off the breakpoints, let the browser do its thing for a bit, and then when I get to a point where I'm familiar with, I'll re-enable them like I have right now. So I'll try changing the host name again, and we're back where we need to be. And from here, I don't see a whole lot of information, a lot of useful information yet. But I know it's going to be happening somewhat soon, so I'm just going to step through the code operation by operation and just see what we find. Nothing. Oh, here we go. Now this, I'm not entirely sure what this is, but I have an idea. Now it's about the same length as an SHA-1 hash sum, and we know from the header that SHA-1s are probably involved. So I'm wondering if that might be the SHA-1 sum of my password. Now I could try going through the debugger more to figure that out, or I could just try taking the hash sum of my password, which is what I'm going to do, because that's a lot easier. So I'll just do echo and then my super secure password into SHA-1 sum tac for standard input. We'll compare that to the other one, and we see that they are not the same. Now this is something that used to trip me up a lot a few years ago. echo will always append a new line to the end of the command, or to the end of the string that you give it. And when that gets passed into SHA1sum, it's going to include that in the signature. So that's always going to be different because you have more characters in there. So instead of echo, we'll try to use printf. Use printf. There we go. That looks familiar now, doesn't it? So now we know what this hash sum is, but the question is, why is it here? Going by what we know with HMAX, we know that there has to be a pre-shared key. Normally that's just the password, but it appears that here they may be using the password hash for the password. I don't know why, but if it works, it works. So when we get to that stage, we'll give it a shot. Moving on, we can keep stepping around. See a lot of not terribly useful stuff. Back into the main function. Keep going. We do see something here. So we know that a date is being used in the HMAC. Normally it doesn't really matter what time zone you use, because the server will just read the time zone from the request and say, okay, we'll use that. This doesn't do that. So this little thing here that says to UTC string is rather important, so we're going to note that down too. Moving on, we can see back into the main function. And now is the most important part. So for an HMAC, you're taking a message and you're signing it so that nothing can be changed in that message. So if we have even the slightest bit of that message incorrect, it's just going to flat out fail. It won't say close but no, it will just say no. But here, we find out exactly how that message is built. We see that we have this variable here, which would be our HTTP verb, which is a post, appended to, or with a space, and then our path, then a new line, date, the UTC date, another new line, and then our message body. So that is the format that we use for our HMAC message. And we can try to guess this, but I can say from experience that it's not a very good idea. It's very hard to guess the correct combination when you have very little knowledge. And I could spend hours upon hours hammering away at that, or I could just pull this up and fiddle with the code for a bit. So now we know a few things. We know the message format. We have an idea of what we may need to use to sign it. So that may be enough to try and make a proof of concept. So that is what I did. I made a quick little Python script, a very ugly Python script. Let's see. So first up, I just import some standard libraries just for base64, hashing, time, that sort of stuff. And we have our known credentials, and then a function that I just found on the internet. I don't remember where it came from, but if you just look up HMAC function, you can probably find it. And this just makes the signature of an HMAC message, or makes the HMAC signature for a message with a key. And then down here, I've hard-coded some more values. We know that for our current request, it's going to be a post with the path to change the hostname and the body to change the hostname. And then for the date, I'm just gonna copy the format that I saw in JavaScript, and then again we use GMT time or UTC time to make sure that it's in that time zone. Then we'll construct our message using the format that we just found. We have our verb, space, path, new line, date, new line, message body. And I'll print that just for debugging, and then I will create the SHA1sum of my password. Print that for debugging, and then the real special stuff, we'll make the signature using the message that we just built and the SHA1sum that we just created. We'll print out the date auth header, and then we'll print out the HMAC SHA1 date header using the information that we just built. So we have our pre-shared key ID, and then our signature. separated by a semicolon, and base64. So let's see if it works. So we have our two headers down here, and we know that it's trying to set the host name to Bork. So we'll go back here. We have the host name currently set to Bork2. We'll change that to Bork, and then we will switch out our headers, and remember to remove the old date off one. And fingers crossed, we won't get a 401, hopefully. This NAS tends to take quite a while, which is either a very good sign or a very bad sign. Looks like it was a very good sign. We have a 200 OK. We successfully changed the hostname to Bork. So now it appears that we can write our own HMAC header, or authentication header. And just to check this, we'll go back in, change some portions of the request. So let's try a little command injection attack. We'll try the semicolon to break out of the current command, and then reboot to reboot the device. Run it again, copy our headers, paste our headers back in, and change our request. And if we're very, very lucky, the device will reboot. Now we know that it takes a little while, but I happen to know on fairly good authority that this probably won't work. This device is fairly resilient against command injection attacks, but we don't know that until we find out. And without this ability to create new headers, we simply wouldn't have been able to find that out. So yeah, we see that our host name has now been set to Bork characters reboot. Not ideal. So we'll just change it back. But as you may have noticed, this is terribly tedious. So currently, I have to go in, modify this script, change a whole bunch of values, run the script, copy all these values over, modify my request, and then resend the request. I don't want to do that for every single request that I want to generate. Moreover, I'd like to use automated tools like Scanner. It has its ups and downs, but it can be quite useful. And this simply won't work for that. So, since we're using Burp, how about we create a plugin? Now, Burp has this wonderful thing called Extender, which allows you to write plugins in, I believe it's Java, Python, and Ruby. I decided to use Python because that's what I had wrote the initial proof of concept in. That was probably a bad idea because in order to use Python, you have to use a weird abstraction layer that basically takes Java and Python and squishes them together. That's a little finicky. It'll work, but be prepared for things to be weird. So I have that plugin somewhere around here. Here we go. So again, we're just going to import our standard libraries for base64, hashing. We're also going to import RE for regular expression. And we're going to import some stuff from Burp, such as date and Burp extender and listener, just so that we can actually write the base of our plugin. I have hard-coded a password, because for our current testing, or for what we were doing, it really wasn't an issue. We didn't have a whole bunch of different users trying to use the same thing. So just for the sake of not making it super complicated, we'll use a hard-coded password. We also have some documentation on highlighting, because pretty colors. And then down into the meat of it, we set up our plugin, the main class for it. It's going to be using the iHTTP listener class, which essentially just it sees all HTTP requests that go through Burp. And in it, we're just going to set a blank session key for other stuff. We're going to register some callbacks. Essentially just says, hey, the plugin exists, the plugin has come to life, and it's good to go. And register our HTTP listener so we get our HTTP messages. And then down here, we set up our process HTTP message function. And this is what gets all of those HTTP requests and responses. So once we have those requests and responses, we're going to take out the info using some built-in Burp tools. Going to take the headers out of that, again using built-in tools, take the URL, the path, and the query. Although I think the query in general isn't required for this, but since we have it, we may as well use it. Now down here, I'm doing something a little different. This is something that we haven't gone over, but this NAS device has decided that instead of normal sessions, it will just give a client a session key and a response and say, hey, just use a numerical session ID as your username, and then you can use that for a session token. So we'll have to keep an eye on that. And if we see a session key coming back in our response, we'll pull it out, note that we found a session key, and then store that for later use. So after that, we're going to make sure that the header make sure that the request contains these authorization headers. Because if it doesn't, it may not even be a request to this device. It could be running out to Google or China or something. We probably don't want to send them our authorization headers. So we're going to not do that. We'll pull out our method, pull out the request. Again, this is all using some built-in functions provided by Burp. And within Burp, you can actually see a lot of these API calls. We pull out our date, we create our password SHA1 sum, and then we're going to extract our username using a function that I've defined below. We'll get to that. And we take that out of base64, turn it into a normal string, and this, for the most part, allows us to deal with some other users and those strange numerical usernames for sessions. And then we're going to see, hey, is the username a digit? And if it is, it's going to be a numerical username, and we're going to be looking for that session key. If we don't have the session key, or if we do have the session key, we're going to set the SHA1 sum or the HMAC to the session key. If we don't, we'll echo an error and highlight things red to say, hey, something's broken. So now that we have our password or session key, whichever one may be applicable, we'll take all of the information that we pulled out from the request and generate our HMAC message. Again, using the same format before. It's the post, or the verb, the path, new line, date, new line, and then the body. We'll make our HMAC signature using the same function as before, although I think I may have cleaned it up a bit or made it worse, whichever works. So now we have our HMAC, or our signature at least. So we'll need to add that to our headers. And for some reason, Burp was being rather ornery, so I just decided throw out all of the headers, go through the headers. If it's one that isn't related, just add it back in. And if it is one that we're looking for, skip it. And then after that process is finished, we add our new date header, or date auth header, and then our new authentication HMAC SHA1 date header. Again, using the username, which is either our username or the numerical session ID, a colon as a field separator, and then our HMAC signature. And we'll set the new message and do some highlighting, whether or not it's a normal request or a request with a numerical session ID. And then we'll set the new request and let it run. And then there's just some helper functions down here. There's the one to make the HMAC signature, the one to check for a header, which is just, yeah, it's not even regular expression, it's just checking to see if it's got that in it. And then extract username, which it's some very simple regular expression, looking for the header and pulling some stuff out, and dealing with base64. So that's all well and good, but does it work? For the most part, I think it does, and we'll find out. So I'll see if I can find it. Here we go. I'll load the plugin. And just to be safe, I'm going to reload this page. Because remember those numerical session IDs? those have probably already been sent, so Burp will not have been able to intercept them. Our client knows them, but Burp doesn't, so that's going to cause some problems. So let's just avoid that. Go back to the NAS, log in. Again, using our super secure password. Log in, and hopefully we'll see some nice pretty colors. Indeed we do, a whole bunch of green. So that means that Burp has successfully generated a new header, or a new authentication header for this request, sent it off, and judging by the 200 OKs, it appears to be working. Now there are some cases where this fails, but this is a very simple plugin that just allows us to do our manual scanning and some basic automated scanning, which, you know, how about we try that now? So to do this, I'll just use Burp's scanning facilities. I'll go to live scanning. I'm going to set up a very strict scope for this because I happen to know where some fun stuff may be. And Burp's scanner tends to be a little sluggish, so we'll give it a helping hand. So we'll say 42.0.15/apps file browser. We'll set that up. We'll go back to our scan queue, and how about we generate some requests? Just so Burp has something to work with. And there we go, it's doing its thing. You can see the request number flying up, and hopefully it'll find something soon. But while that's doing its thing, I wanted to show something a little interesting here. I meant to cover this earlier, but we know that the path for these requests is included in the HMAC. But what if we change it regardless? So what if we just change the path to something that doesn't exist? Just a non-existent endpoint. We see that it's a 404, so it's going to be checking to see if the API endpoint exists first, and then doing authentication. But what I find interesting about this is that it just dumped the path right back to me. And the content type is text HTML. So what if we give it some script tags? How about we give that a shot while the scanner's doing its thing? So we'll just add a script tag, and then alert, and how about a smiley face? So there are script tags. Just make sure that they are URL encoded, and I'll do that using Control U. Send it again, and hey, we now have script tags in our response. So we know that it uses a post. Can we use a get? We cannot. However, we can still coerce clients into sending a post request. So to do this, I'm just going to use engagement tools, generate CSRF. And this essentially just generates a page that when someone goes to it, they click a button and they issue that request. So we'll give it a shot. Again, we're just waiting for the scanner to do its thing. So we'll go here, click the button, and there we go, a smiley face. And we can't do much with it yet, but we may be able to come back to that. So let's go back to Burp Suite, see if our scanner has found anything fun. It has not, so let's try and speed it up a little bit by canceling the ones that we're not interested in. Let that do its thing. Oh, I think it may have found something, and indeed it did. So what we have here is path traversal, which you can see that we've essentially told the application, hey, I would like to get a file from apps file browser images list, and then given it a file that happens to be way further back in the file system, and then back down a bit, which also happens to be Etsy shadow, and also happens to contain the root password hash. So ideally, we would be able to take this hash, crack it, and then log in as root, and have root on the device. But truth be told, that doesn't work here, because the file browser application is running in a container, so it does not have access to the rest of the system. We can still do some fun stuff in the container, and it just so happens that, remember that request that generated an error? Or the request that generated an authentication error that so kindly gave us a path? What if we just take that path and use it with the path traversal vulnerability? So we'll go back here, send this to repeater so we can play with it. Replace Etsy shadow with something a little more interesting. And there we go. We have this big old chunk of source code with a rather ominous warning on it. Oh well. And since this is Python, although we may not directly know where all of the other files for this program are, we can probably use all of these imports to figure out where those files are. Because if you know how these imports work and where it's going to be searching for those files, like where the Python path is, you can generally just pull whatever file is being imported, or at least figure out the file name for it. So, knowing that, how about we try and pull something a little fun? So I think back here should be run.py. Nope. Maybe it's one lower. Usually just go through and guess file names, use the imports to figure it out. And we see we pulled run.py, which is the core of this application. And we can keep doing this for all of the other portions of its application, pull down the source code, and then analyze it statically. And since it's Python, we can read it directly. We don't have to reverse engineer anything. We can run all of our fun tools like Bandit, source code analysis, and try and find more fun vulnerabilities. But in order to get root, it appears we don't need to do that, because our browser, so handily, it stores the password hash somewhere. Like, the browser has to know how to sign these HMAC requests, so it has to have that pre-shared key. Now, going through the Burp, all of the Burp requests, we can see that it never sends a cookie for any of this. It's not using cookies. And we can verify that by going into the developer tools and going into application, and we can see that in the cookies, there's nothing there. But in local storage, we see a very familiar string, our password hash. So normally people try to dump, I don't remember the endpoint for it, but you try and use cross-site scripting to dump the cookies. We can just dump local storage instead, so we can still access that value, theoretically. So if we have that value, like if we manage to get some poor user to click on our link, fall victim to our CSRF attack with XSS, and pull that value, we have everything we need to sign those requests. So let's give it a shot. So we'll close out our old CSRF proof of concept, close out that, go back to this. Now, let's see if I can remember remember the function to pull this information. So I think we're going to use console.log to get the information out. If I were a real attacker, I'd probably be sending it in some sort of like GET request to a server. It's not any harder to do, but just for the sake of the demonstration, we'll use console.log. Let's see, what would that be? I think it's local storage.get to get something from local storage. And then we need to supply the key to get. Now, that appears to be Lacey sign. So we'll copy that because they have weird capitalization that I'm going to forget. Paste that in. Close out the parentheses. And hopefully that'll work. And again, we'll have to make sure that everything is URL encoded. It appears it is. We'll generate another CSRF proof of concept. Copy the link. And make sure we have our developer tools up so we can actually see the console. And we'll try going to the page. So now we're at our CSRF proof of concept, and for what it's worth, you can automate this. The user doesn't actually have to click a button. I just didn't click a button to set that option. So we see that it didn't work because I forgot to change the request back to a post request. So there we go, change it back. We'll generate a new proof of concept. Copy the link, go back to our browser, and test it out. And with any luck, we'll see our password hash show up in the console. We do not, because that is not a real function. All right. How about we consult the Oracle? Well, not terrible Oracle, as in Google. Kind of terrible. So, what would that function be? Let's try get item. There we go. So this is the life of a security analyst. You think you know what you need to do, and then it simply doesn't work. So you have to consult Google. So now that we have our function that we want to use, we will stick it in and hope that it actually works this time. So it did not, because Burp decided not to update it. Because apparently you have to close out the entire proof of concept thing, because Burp can be a little ornery sometimes. Or I just screwed something up. Oh. So we'll copy that function again, stick it back into our proof of concept, use engagement tools, generate proof of concept, copy the link again, and hopefully for the nth time, it's still not working. But I think this is probably a good place to call it. I hope you can take my word when I say that this actually does work when I remember the correct function. And it allows us to just pull that item out of the browser's local storage and send it off to some remote server, or even a local server if I happen to be on your network already. And then I can just use that instead of in here using that password. I can just skip using a password, skip generating the SHA-1 sum, just use that SHA-1 sum that I pulled through XSS and sign any request I want, including ones that allow me to turn on SSH, change the admin password, and then log in as root. So, I think that just about covers it. We took our browser, tried to do some fun stuff using Burp, found out that the NAS device won't let us. So we opened up our browser again, used the debugger, set some breakpoints, used XHR breakpoints, went back through the stack, back down, found some fun stuff, reverse engineered how these signatures are being made, and then we managed to make a plugin, a proof of concept, and then the plugin, use the plugin, give it a shot, and good to go. So, it appears a small little voice is telling me a function that might be helpful for this. So, before we call it, let's try, what is it? Window.local storage .get item. So hopefully this works. Now, ideally this would have been something that I wrote down before the stream, but truth be told, we found this last night because we thought this was interesting. And this is the wonderful thing about working with very nice coworkers. They're very good about saving you. So let's try this one more time. Still not working. Probably because I screwed something up.
It still says storage.
It does. Why does it say that?
Just manually update the HTML.
Let's try sending it, see if that's what's bugging Burp. So we'll copy this again, test in browser, copy, submit. Search.get item. So now it's actually updated, but it's still not giving us what we want. It should be window. Yeah. In case you were wondering, this is how it goes. Information security, doing security assessments. Sometimes it just doesn't work. And when you're doing a demo, doubly so. Because demos never go well. Seems a small voice may be back. Ah.
Yeah,
No, it is. It is lowercase.
Yeah, it's all
I don't know. But you guys get the idea. I guess do we want to go into Q&A, or I mean, I can keep poking away at this if anyone has questions. We'll need to rely on the small voices because I cannot see chat. Hey! So, it finally worked. Because of all the things that JavaScript is very good about not caring about, it appears that capitalization is not one of them. So, now that we used window.localstorage.getItem, we were able to dump the administrator's password hash. Using that, we can generate any request or any authenticated request that we want. Again, enable SSH, change some passwords, log in as root. The device has been completely owned.
Okay. Weasel my way back in here.
All right.
All right, guys. Well, I mean, I guess that pretty much concludes our technical demo. It appears that nobody has any questions. We're willing to take follow-up questions, post a live stream. If at a later time reviewing the content and something comes to mind on maybe a different attack vector or a way you could have gone about exploitation, feel free to reach out to us on social media. We're available on Twitter, LinkedIn. Yeah, but outside of that, hopefully you guys enjoyed the content. ISE Labs, as I stated, is a newly founded division here at ISE, where we're going to regularly be hosting content such as live streams, publishing blog posts. We're actively working on a handful of research projects, and we'll continue to do so for the foreseeable future, all of which are going to result in content such as this live stream. So yeah, be sure to check us out. We'll be posting updates fairly regularly on when we'll be hosting live streams. They are recorded, so you can watch them at a time that better suits you. If you have feedback on how we can improve, a better time that we could host these live streams, etc., by all means, provide it. We want to, do you guys a service in hosting this content. Outside of that, DEF CON is coming up. Hopefully most of you guys will be there. If you don't know, ISC, wrong shoulder, ISC, we run IoT Village. So come check us out. We'll be running some contests such as So Obviously Broken, which is our router/embedded device capture the flag event. We'll be having a 0-day contest like we've had the past several years, where there'll be a myriad of devices for you guys to poke away at and hack. The best vulnerabilities receive prizes. We'll be publishing that list in the very near future, so please stay tuned to the IoT Village Twitter. But outside of that, I mean, that's pretty much all we have for you. So we look forward to hosting these events, and we'll see you guys soon. Thanks for tuning in. Take care.